right, so in this video, I just wanted to show you an example of kind of carrying out and writing up a simulation from start to finish. So this says a school debates club has 10 members, 6 females and 4 males. If the team decides to pick 2 members randomly to participate in a debate, what is the probability that both of the chosen members are female? We want to use a simulation to estimate the probability. So describe the simulation procedure below, and then use your calculator to carry out 10 trials of the simulation to estimate the probability. So again, this is just to kind of show you how you can use your calculator to do these sorts of things. First of all, this is not a hard probability to calculate. All right. The odds that the first person is going to be female is 6 out of 10. The odds that the second person is going to be female is 5 out of 9 because you have one less female and one less person to choose from, which is 30 out of 90, which is 1/3. All right, so not hard to calculate, but as we already talked about, simulation is a valid technique because over a large number of samples, it'll approach the true probability. And when it's not this easy to calculate the true probability, simulation might be your best way to go. All right, and we can use examples like this to prove that it works. All right, so what we can do here is if we're going to describe our simulation procedure, we can just it's sort of similar to what we did for experiments and samples, but we can say something like, all right, assign the females numbers 1 through 6. Assign the males numbers 7 through 10. All right. Then we could say generate 2 random numbers between 1 and 10. If you get the same number, generate 2 new numbers. All right, so we're addressing what happens if you get like a 7 and a 7. Obviously, that can't happen in real life because you're not going to pick the same person twice. So how do we deal with that inside of our simulation? And then just say 2 numbers between 1 and 6 constitutes a success. All right, so that's our general procedure. Now I want to show you how you actually can do that on the calculator. So if you go to the math menu and you scroll over to probability, choice 5 is random integer. And I can go in here and I can say 1, 10, and that will generate random numbers between 1 and 10. And if I hit enter, you'll see that I get a whole bunch of numbers, 5, 8, 1, 4. All right. Now I'm going to clear these out and I'm going to reset my memory. All right, so I'm resetting my memory. And then I'm going to go back here and I'm going to go to random int and I'm going to go 1, 10. And notice that 5 there. I bet you the next one's going to be 8. I bet you the next one's going to be 1. I bet you the next one's going to be 4. All right, that's the same exact sequence I got just before I reset my memory. All right, let me reset it again. Math, probability, random int, 1, 10. All right, so there's the 5, there's the 8, there's the 1, there's the 4. All right, turns out that computers can't actually truly be random. They just kind of simulate being random. through a series of calculations. But when you reset the memory, you're kind of resetting that calculation to the starting point, and you end up getting the same results. So anytime you generate random numbers or run a simulation and you're using like a calculator versus like rolling a die or flipping a coin, it's important that we do what's called seeding the random number generator. All right, so let me explain what that means. So let me reset the memory again. So mem reset. All right, seeding the random number generator basically means plugging in a starting value. All right, and that starting value gets plugged into the random number calculation. And if you put in a different number, you get totally different results. If you put in the same number, you get the same results. All right, so the way we seed the random number generator is you just pick a number. So let's say I picked 50, and then I hit the stow key, which is right above on. So it gives that little arrow there. So there's the stow key. And then I go to math probability rand. And what that's saying is take 50 and store it in the random number generator. And that's going to kick off a new sequence of numbers. So when I do this, and now I go to random int 1, 10, I'm going to get totally different results. And I'm not getting that 5814 that I was seeing before. All right. So you can use calculators for random number generation, but it's important that you just seed. And it's important that you don't seed the same number as somebody right next to you, because if you do, you're going to get the same exact result. So usually anytime before I run a simulation, I'll just go and type in a bunch of numbers. All right. So just a big, long bunch of numbers. And then I go to store, math, probability, rand. And that just guarantees that my results are going to be different than anybody else's when this calculator is generating it. Because otherwise, you can get into this problem where you're getting the same results as everybody else because all the calculator memories have just been reset. Or if you seed it with a number like 5 and a bunch of other people picked 5, you could get the same results. But as long as you're putting in different numbers, you will get radically different results. It's not like putting in a 5 is going to give you similar things to putting in a 6. You just have to plug in a number, and then that causes it to spiral off in a completely different direction. All right, so now that I've seeded it, I can actually go here to math probability random int 1, 10. And because I'm picking 2 people, I can also put a 2 there, and then it'll give me 2 random numbers at a time. So I could go through and say, all right, this time, the first time I got a 1 and a 5. All right, the second time I got a 7 and a 9. The next time I got a 6 and a 1. Then I got a 6 and a 5. Then I got a 6 and an 8. Then I got a 3 and a 9. A 7 and an 8. A 6 and a 4. A 7 and a 10, and a 10 and a 3. All right, and that's what I was saying. If you ever got the same number twice, you could just hit enter again and get 2 new ones. So we said that 2 numbers between 1 and 6 constitutes a success. So there's a success, there's a success, there's a success. Nope, nope, nope. Yep. Nope, nope. All right, so out of our 10 trials there, we ended up with 4 successes because there were 4 times where our numbers were between 1 and 6. So using our simulation, we had 4 successes out of 10 trials for an experimental probability of 0.40 or 40%. Right. And this is just kind of the process that you would run through when doing your simulation. All right, you try to lay out all the steps so that if I handed this sheet to somebody else, they would understand what they needed to do, hopefully without having any questions, and they could just carry it out on their own. You then actually carry out the simulation, you figure out how many successes you have, and then you calculate your experimental probability from that. Now, we saw that the real probability is 0.33. If we had done this, thousands of times, we'd probably get pretty close to that 0.33, if not, almost exactly at that 0.33. When we're only doing it 10 times, it's actually impossible for us to get this. The closest we're going to get is either 0.3 or 0.4. And we did get 0.4 on this one. So again, this is just the process so you can kind of see it start to finish of how you run through a simulation, how you write it up, how you can use the calculator to conduct it, and then how to write sort of your conclusion sentence. And again, main thing with the calculator is just remember that it is important to seed the random number generator. Otherwise, you might end up getting the same results as everybody else, which then kind of defeats the purpose of trying to do something randomly. So again, you just pick any random number, just hit the keyboard a whole bunch of times and then store it inside of math probability, rand, it's the very first one. And then your random number generator will be different than anybody else's. All right, so that's it for this. Hope it was helpful. Have a great day, and I will see you when I see you.